Have you ever pondered the intricate relationship between energy, work, power, and force in physics? These concepts, while seemingly distinct, are actually closely connected, forming a fundamental part of our understanding of the physical world. Firstly, let's delve into the concept of energy. Energy, simply put, is the capacity to do work. It is the driving force that enables us to move, think, and indeed live. Energy can be found in various forms, such as kinetic energy, which is the energy of motion, and potential energy, which is stored energy. The formula for kinetic energy is half times mass times the velocity squared, while potential energy is calculated as mass times gravitational acceleration times height. Moving on to work, it is the amount of energy used to move an object. The formula for work is force times distance times the cosine of the angle between the direction of the force and the direction of the distance. Now let's talk about power. Power is the rate at which work is done or energy is transferred. It's about how fast you can get the work done. The formula for power is work divided by time or force times velocity times the cosine of the angle between the direction of the force and the direction of the velocity. Finally, there's force. Force is something that can cause a change in the speed, shape, or direction of an object. It can be calculated by the formula, force equals mass times acceleration. So how do these concepts relate to each other? Well, energy, work, and power are directly proportional. If energy or work increases, so does power. If force or distance increases, then work also increases. If velocity or time increases, power increases as well. Force relates to energy, work, and power because it is the factor that influences work and power. If force increases, work and power also increase. Force is also a factor that influences the change in energy because force can do work on an object and change its energy. In summary, energy is the capacity to do work. Work is the energy used to move an object. Power is the rate at which work is done or energy is transferred. And force is something that can cause a change in the speed, shape, or direction of an object. These concepts are interconnected, each influencing and being influenced by the others. Understanding these concepts and their relationship to one another can give us a deeper insight into the workings of the physical world. It allows us to grasp how energy is transferred and transformed, how work is performed, and how force and power are exerted. So next time you push a door open, remember, you're not just applying force, you're engaging in a complex dance of energy, work, power, and force.
Ever wondered how different forces work in physics? How they interact to shape the world around us? Today we delve into the intricate world of forces, the invisible hands that sculpt the universe. Consider Newton's laws of motion. First, the law of inertia. A body at rest tends to stay at rest, and a body in motion tends to stay in motion. No mathematical formula for this one, but it's a fundamental principle that lays the groundwork for understanding forces. Then, Newton's second law, force equals mass times acceleration, or F equals ma. Force is measured in newtons, mass in kilograms, and acceleration in meters per second squared. Newton's third law? Every action has an equal and opposite reaction. Again, no specific formula, but an essential concept that defines the nature of forces. Next, the gravitational force, defined by Newton's universal law of gravitation. Force equals the gravitational constant times the product of two masses, divided by the distance between them squared. Then, we have the electromagnetic force governed by Coulomb's law for static cases. Force equals Coulomb's constant times the product of two electric charges divided by the distance between them squared. Frictional force depends on the context, but generally it's the product of the coefficient of friction and the normal force. Centripetal force, that's mass times velocity squared divided by the radius of the path. The force exerted by a spring is explained by Hooke's law. Force equals the spring constant times the displacement from equilibrium. Buoyancy, or the buoyant force, equals the density of the fluid times the volume of the fluid displaced, times the acceleration due to gravity. The Lorentz force involves electric and magnetic fields. It equals the electric charge times the sum of the electric field and the cross product of velocity and magnetic field. In hydraulic systems, force is calculated based on Pascal's principle. If a force is applied to one area, the output force on another area is the input force times the ratio of the areas. Finally, the force exerted by a photon, such as in radiation pressure, is calculated using the momentum of the photon. However, this is generally very small. In summary, forces in physics are complex and varied, each governed by its own set of principles and mathematical formulas. From Newton's laws of motion to the forces exerted by photons, understanding these forces brings us closer to understanding the fundamental workings of our universe.